In this video, I will demonstrate how to implement continuous integration or CI pipelines with Tekton on Openshift using the Cloud Native Toolkit. From the Cloud Native Toolkit website, go to Workshops and select the lab CI pipelines with Tekton. Before you begin, make sure that you have the cluster installed with the toolkit and the workshop. You can see the instructions in setup workshop environments. It's very easy. For the CLI, I'll be using my terminal, already installed the toolkit CLI. Return to the CI pipelines Tekton for the next step. The next step is we're going to log in into the Openshift console. If you use IBM Cloud, then log in as your normal user account in IBM Cloud. If you have a cluster anywhere else, then you have to select the IBM Toolkit realm. So go to the console. As you can see, I already configured the workshop. So now I see the IBM Toolkit option here for this server or cluster that is running on premises using VMs on a private network. So click in here and then use one of the accounts, user 1, user 2, user 3, user 4. Those are the accounts that are set up for the password. Password is password. You can change this later or continue with it. So you can see if I selected project 1, I'll be accessing projects that start with project 1. If you selected user 2, you will see project 2, and that will be the prefix that you'll be using for your namespaces. That way we can have multiple students running the workshop at the same time. Now return to the next instructions. Next step, we're going to set up an environment variable with the user that we selected. In my case, I'll be user 1. So I'm going to go to the terminal and copy this command. So let me move my window. I'm going to paste it. If you have a different user, you can hit it delete and then change it to 2 or 3, user 4. I'm going to be user 1. For the next step, we're going to log in the terminal. If you use IBM Cloud account, then you can log in with your IBM Cloud account. If you are using one of these user accounts for the workshop in a cluster that is located in a different place, then copy the command to log in as that user. So copy the command, go to the terminal and paste it. The next step is we're going to set up an environment variable for the project prefix. Like I said, I'm going to be user 1 using project 1. If you are user 2, you'll be using project 2 and so on. Copy the command and paste it in the terminal. And again, you can use delete to change it to 2 or 3, in my case 1. The next step in the lab is we're going to copy this command that is a Openshift Sync command. It's going to use project 1 as a prefix or project 2 as a suffix. We're going to use dev. So this will be the project or namespace that our CI pipelines will run. So copy the command and paste it. This command will create a new project if it doesn't already exist and copy a few config maps and secrets from the tools namespace where the toolkit was installed. These config and credentials are going to be used by the pipelines to access the Git server and the different tools that the pipeline integrates with. Now let's go to the next step. In the next step, we're going to use the developer dashboard, use one of the starter kits. In our case is Go. We're going to fork the repo. We're going to log in into the Git server with our user 1 and password, or user 2 and password. Rename it to app. This is very important because the GitOps will be using that as a keyword. And then we're going to fork it. So let's go back to the console. In the console, you can select the menu, and these are the tools that the toolkit install and the workshop configure. Select developer dashboard. And if you're not already logged in, so the Git server can authenticate you and the developer dashboard, sorry. These are the tools that developers usually use to get to them, similar ones of the Openshift console menu. The Learn is a couple of tutorials and education links if developers want to learn more about cloud native development, OpenShift, and so on. So go to Starter Kits. In this section, you will see Starter Kits. Beginning, we have Angular, we have React, Java, Go, Node.js. We also have some solution apps that we're going to be using for follow-on hands-on labs. For this case, click on the Go template or pattern. Once in the Git server, you'll be click the button that says fork, and then it will prompt you for username and password. So go ahead and use user 1 if you're user 1, or user 2 or user 3. Password is password. Now this is the important step. Go ahead and change the name of the repository to app, and click fork. As you can see, now we have our own copy of the application located in a Git repository. Return to the instructions for the next step. Let's copy the command to clone the Git repository locally and paste it in the terminal. Now we are going to create a new pipeline for the current Git repository that we just cloned. We're going to use the Openshift CLI with the Toolkit plugin to run OC pipeline. Copy this command. Go to the terminal window and paste it. The command detected that the Git URL and the programming language in the folder, and it offered me pipelines available for Go. In the toolkit, we have pipelines that support Edge with Go. In our case, let's select the normal IBM Golang pipeline and press enter. You can hit arrow up or arrow down to select. It's asking us if we want to scan the image. Go ahead and hit enter to detect the defaults. When it's done, the command, you will see that the pipeline will start running. You can use the Tekton CLI to follow the logs or describe the Tekton pipeline run, or you can go back to the console. So let's go to the Openshift console. Select the project 1 dev, and now you can select pipelines and select the pipeline run that just started. Here you will see the pipeline running. You can see the logs. You can also see the pipeline definition. You select pipelines, select the pipeline, and this is the pipeline definition. You can also see the tasks that compose this pipeline. You can also see the parameters that the pipeline takes. And you can also see the YAML definition of the pipeline. You can follow the progress of the pipeline using pipeline runs and selecting the instance that is currently running. The pipeline will take a few minutes. I will fast forward the video. Now that the pipeline is done, let's review the tasks. The test task runs unit tests and did static code analysis using SonarQube. SonarQube was one of the tools installed by the toolkit. Let me open SonarQube from the menu. Go to the top menu and select SonarQube. Select the project and select the application. SonarQube is a tool that is used to check code quality from code smells, code coverage, security problems with the code. SonarQube can be used in cluster or hosted outside the cluster. If you have your own tool to do code coverage analysis or code quality, you can modify the pipeline and swap the task. Let's return to the pipeline. The next task, builds the container image and push the image to the internal registry in Openshift using the tag of the git commit hash. The next task, deploys deploys the application just to check that there's no problems with the YAML and that the app starts. The next task does a health check using the ingress or route to make sure that the YAML to expose the application is correct. If the server is not exposed, this is a task that you can remove or replace. The next task will look up in Git for the version tag and increase it and create a new tag with the semantic versioning. Let's see the version of the Git repository. Open Git dev from the menu and click releases. Menu, Git dev. Select the repository and check out releases. The tags will be created here. Return to Openshift. The next task, tags and push the image to an external image registry, or you can use an internal registry. Let's see the image versions on the image registry. Open image registry from the menus. Select the project 1 dev. Select the image stream app. Scroll down and you will see the image tags for 100 and also the Git hash. Return back to the pipeline run. The next task will do a security scan of the image. The task is configured to detect if you're using IBM Cloud Registry. If it's using IBM Cloud Registry, it will do an image scan using IBM Cloud. If not, it will be using an open source tool called Trivi. The next task will package the manifest YAML files for the application and push them to the artifact server. In our case, we're using Artifactory. To see the Helm charts in Artifactory, open Artifactory from the menu. Select Artifactory, Artifacts, and you will find generic local, and you will see the Helm repo with one application up with version 100. Artifactory can be in the cluster or hosted outside the cluster. If you have a different location where you want to store the Helm charts, you can swap the task for another artifact server. Return back to the pipeline. The next and last task is called GitOps. In this task, a different Git repository with the name GitOps is cloned and updated with the application definition that points to the Helm chart that is located in Artifactory. The application will be deployed to a different namespace for testing named project1-QA. A GitOps controller will watch the Git repository for changes and deploy the app to this QA namespace, and also can be configured for staging and production in different namespaces in the same cluster or a different cluster located in a different data center or region. Let's see the application running in the QA namespace. Go to topology, switch to project 1 QA, and this is the application running. Open the application route URL and try out the application using the Swagger UI. You can click in here, or you can select the application and click the route. This is a microservice with an endpoint API. Only has one endpoint called health. You can try it out, click and try it out, and execute. You will get back a response of 200. Return to Openshift. Return back to the pipelines, select pipelines. There's no pipelines in the QA namespace. Switch back to the dev namespace and select the last run. Now let's see how we can start a new pipeline run. Let's make a change to our application and push the change to the Git repository. Go back to the instructions. Copy the command to do a simple change and use Git to push the change. Copy the command, paste the command in the terminal. Press enter. To see this change in the Git server, go back to the Git repository. Click commits, and you will see that we just push a change. You can also verify that the Git webhook is configured correctly. Go to settings, select webhooks, and select the webhook. You will see that a recent event happened. with the git push. Now return to the Openshift console, click pipelines, and you will notice that there's a new pipeline run running. Select the last run. This will go through the same process, so I'm going to fast forward the video. Now that the pipeline run is done, let's verify the last task to see if it's pushing the files to the Git repository. Go to the menu, open GitOps. This is a different Git repository called GitOps under the Toolkit account. Go to QA, find project 1 if you're user 1, project 2 if you're user 2, and so on. This is our application that we're deploying, and that task is updating these files in there. As you can see, you can modify the application in different namespaces, for example QA, staging, and production, by overriding the values. And the requirements.yaml has the location of the repository in Artifactory for the Helm chart and also the version. So every time the pipeline runs, it updates this to the next version. Return back to Openshift. And that's the end of this lab. I hope you finish the lab and continue with the next lab. Thank you.